Can you guys hear me? Can you hear me?
Yes.
Because they completely jacked the room. They came in. You remember how there were desks in all kinds of different directions in this room? With stickers all over them. Do you remember those? Do you remember when you were in the room? Now all that's gone. All that's gone. They moved my camera. They unplugged things. So I just have to make sure you guys can hear me. Okay, look at me. Look at me. This weekend, oh my gosh, this weekend and Monday and Tuesday of next week, the most stunning days of the year. I mean, it's going to be so beautiful outside. I mean, highs in the 60s, low 70s, bright sunshine. I mean, wonderful weather, wonderful weather. If any of you are sick, I'm so sorry. Now listen, write this down. Bear Fence Rock Scramble. Bear Fence Rock Scramble. It's a 1 mile round loop up on Skyline Drive. There's a scramble part of it, rock scramble part of it, where you kind of like, I could die. That's where you're like, you're climbing on these things and you're like, if I slipped, I would die right now. But that's half the fun of it. That's half the fun of it. You could die. You could die. But then you get up to the top and you get this 360-degree panorama. It is incredible. It is incredible. It's like 40 minutes away from here. Just 40 minutes. You go up to Elkton, jump into the park, and go up about 8 miles, go up north 8 miles. It's just incredible. Another place, write this down, Reddish Knob. Reddish Knob. Okay, you can actually drive up to Reddish Knob. I mean, it'll be freezing up there. It'll be freezing, and you don't want to go by yourself because you might die. I mean, I don't know what kind of animals and human beings live up there. But I do know you will see the stars up there like you haven't seen them maybe in your whole life. If you get up there with a telescope or anything, you will see galaxies because it'll be so clear. And that's like a half an hour from here. It's like a half an hour. Reddish Knob, Reddish Knob. Okay, well, enough of that. Stand up, stand up, stand up, stand up. Stand up, stand up, wherever you're at, stand up, stand up. Stretch. Some of you are not standing. I know you're not Christopher Reeves. Stand up, stand up. Stretch. I'd love to see everybody's face. I'd love to see everybody. Where is everybody? Where is everybody? Okay, sit back down, sit back down. I've only got like 25 of you. I'm missing like 6 or 7 of you. Okay, that must mean you're on the videos. Just a second. You should be in class. You should be in class right now. But watch the video anyhow. Watch the video. It's so much better when you're in class. Okay, back to where we were here. We've taken we now have behind us our first quest. Okay, we were beginning to get it. We're beginning to understand the process. For me, this is feeling more natural. I don't know why. Probably for you it's not. I mean, is this feeling more natural for you to come to class and watch me here and work with the videos? I mean, that's what I'm hoping. And I'm hoping all of your classes are feeling more comfortable. I hope all of your classes are feeling more comfortable. We're beginning to settle into a rhythm. I am hopeful in October we're going to be back in the classroom together. I am hopeful in October we're going to be cases are going down. Cases are going down. Okay, let's keep the cases going. Let's keep the cases going down. So social distance like a pro. Social distance like a pro. Okay. Our second quest will be here. I mean, we're going to have one every other week. It's going to be one every other week. So our second quest will probably be not next Wednesday, but the next Wednesday. So one after another after another. That's the way these are going to come. I want lots of evaluations. Our next one will be kind of a limits and derivatives quest. All I asked on the first quest related to limits was graphical stuff. The next one, we're going to have to actually calculate limits. And look at me, you're going to have a limit proof. And so I've given you an example. So what I want you to start with today is I want you to write down I want you to write down all the logic that's in this proof. I haven't put many of the justifications in. But just take a couple minutes, and write down these 8 or 9 lines of this proof, this limit proof.
Dr. Warren, I have a question.
Yep.
When do you think the Quest 1 grades will be in?
Many moons, young brave, will pass.
Okay.
Because I've got so many other things I've got to get done.
Right.
So, but I hope to have them in like a week. I rarely let it go more than a week.
Yeah.
Does that make it? But still, I'd love to have them like today. I'd love like, oh, here are your grades. That would be ideal for feedback, but yeah. COVID.
Dr. Warren, is that a cube root? I can't see it.
It is in fact a cube root, yeah, thanks. It's a cube root, yeah. So yeah, we went from the cube root to the 1/3. The cube root to the 1/3. And if you can't read it, just let me know. I'll read any line you need.
Dr. Warren,
Yep,
what does it say in the second column in the first row?
right here.
Yes.
Okay, this is a parenthesis raised to the 1/3, a parenthesis raised to the 1/3, then it's 5 times -2, 5 times -2, plus the limit as x approaches -2 of the constant 2,
Wait, Dr. Warren, so when it says the limit as x approaches, that's been -2 the whole time, or is that 2?
That's -2, Paris. -2. Sorry, it sucks. You guys have to get this from a Zoom blur. Okay, while you finish writing down, I'm just going to read off the logic in the proof. We're starting and we're asked to show that the limit as x approaches -2 of the cube root of 5x plus 2 is actually the cube root of -8, which is -2. So this is the kind of proof you guys might have to make on our second quest, something like this, where every single step is justified. So our first move is to change the cube root into a raised to the 1/3. And that's just by algebra of the reals. That's just by algebra of the reals. It's not any of our limit tools. Go into Canvas, and go into Files, and open your limit tools. Go into Canvas. You're going to be allowed these limit tools on our second quest. You can have those open on our second quest. Okay, the next line of logic, we go from here to here, where we have this limit as x approaches -2 on the outside, and I'm moving it inside the 1/3 power, so that it's the limit as x approaches -2 of 5x plus 2 raised to the 1/3. Now you go through those limit tools and try to see which one you think justifies that move, that this limit can go inside that 1/3. By limit tool 5, by limit tool 5. And so you would just write that down, you would write it down just like that, LT5 on the quest. Now, look at the next line of logic. We're going from here to here, and I've got the limit as x approaches -2 of 5x, plus the limit as x approaches -2 of 2, all of that raised to the 1/3. Now go through your limit tools, and try to determine which one of those 12 limit tools you would use to justify that move of logic. And I'm going to play singles here. I'm going to pick one person and hit the ball to them. Now don't look down, don't look around, look me in the eye. Let me see, I'm picking Clay. Or is it Clay or Che? Che, sorry, Che. My eyes are shot. Che, do you have anything for me?
2.
You said what?
2.
Limit tool 2. Anybody else have limit tool 2? Raise your hands, raise your hands. Limit tool 2. It is in fact limit tool number 2. The sum of the limit, a limit of the sum is sum of the limits. Okay, look at the next move. You know, it's kind of like what's changing. It's almost a game. What changed from this row to this row? We have now 5 times the limit as x approaches -2 of x, plus the limit as x approaches -2 of 2 raised to the 1/3. What limit tool would allow me to take the 5 and bring it out in front of that limit? Write down what you think. Write down what you think. Henry, you got any ideas for me?
Limit tool 1?
Yeah, Henry, awesome. Limit tool number 1. Limit tool number 1. Perfect. Okay, now the line that we couldn't read up here, we've replaced this limit as x approaches -2 of x with just the number -2. With just the number -2, plus the limit as x approaches -2 of 2 raised to the 1/3. What limit tool, guys, would allow you to justify that you could go from this line of logic to this line of logic? What do you guys think? Which limit tool? Let me see here. Aiden, what do you think? What do you think, Aiden?
It's limit tool 7.
It's limit tool number 7. Very good, Aiden. Limit tool number 7. Now we're almost done, guys. We're zeroing in on the proof. The only thing that's changed in this line to this line is I've replaced this limit with the number 2. I've evaluated this limit to be the number 2. What limit tool would allow me to say that? What limit tool would allow me to say that? as you go through and look at your list of limit tools, which one do you think it is? Miles, do you have any idea for me?
Is it limit tool 8?
It is limit tool 8. Very good, Miles. It's limit tool 8. Now, I mean, the rest of it's pretty much arithmetic. Now we're back in 4th grade or 5th grade. You know, 5 times -2 is -8 plus 5 times 2 is -2 is -10 plus 2 is -8. The cube root of -8 is -2 times -2 times -2 is -2. But all of this is just algebra. We can just get away with algebra of the reals, algebra of the reals. How many people followed the proof? How many people followed the proof? You're going to have to make a proof like that. You're going to have, you're going to start here, and I'm going to say, prove that, and you're going to have to produce all of this. You're going to have to produce all of this. You can do it. You can do it. You can do it. Okay, stand up again. Stand up again. I can already tell you need to stand up again. Okay, let's see. Run in place, 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 run in place. Shadow box, 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 shadow box. Okay, sit back down, sit back down, sit back down. Go to grid view, go to grid view, go to grid view. Go to grid view. Now shadow box, shadow box, shadow box, shadow box and grid view, shadow box and grid view, shadow box and grid view, shadow box, shadow box, shadow box, shadow box. Che, you're getting the hell beat out of you. Che, okay, stop. Make me number one, make me number one, make me number one. Okay. This is me, this is me, this is me, this picture's me. I am what in that picture? What am I doing? Smiling, okay? And the reason I'm smiling is because I like these kinds of problems. The reason I'm smiling, and like guys, when your professor says stuff like that, freshmen, when your professor says, oh, I like these kind of problems, it means, oh, this will probably show up on the test. That's what that means. That's code for, oh, I really like these kinds of problems. You should be thinking, warning, could show up on test. Warning, could show up on test. I like these because they're somewhat clever. They don't give you functions, but they ask you to show the limit goes to something. You're like, what the hell? Seriously? You're not even giving, they don't tell me what f of x is. They don't tell me what g of x is. But they do tell me that the limit as x approaches c of f of x goes to the number 7. Sorry, Lainey, I had to bring you back. The limit as x approaches c of f of x is 7. Also, the limit as x approaches c of g of x is the number 4. And then they have the gall to say, well, what is the limit then of the square root of 2 times f of x minus 3 times g of x? And when you first see these kinds of questions on a quest, you're like, whoa, wait, what is f of x? What is g of x? Give me functions. I can't do this. But the reality is you can do it. You can use your limit tools. We're not making a proof. I'm in your face. We're not making a proof. We're just going to find the limit. Yeah, I like that, Miles. You backed me out of the way. There, backed me out of the way. Okay, so we've got that limit. We've got this limit, and you guys are going to help me with this. You're going to help me with this. If I was doing this, the first thing I would do is this. The limit as x approaches c of 2 times f of x minus 3 times g of x. I'm going to turn that square root into a what? I'm going to turn that square root into a what? A power. Every time in this class you see a square root, every single time, turn it into a power. It'll save your butt. All right. I don't know what c is, I don't know what f of x is, I don't know what g of x is, but I'm still going to be able to answer the question. Can I take the limit inside the power? Can I take the limit inside the power? Do we have a limit tool that allows us to do that? Do we have the power to do that?
Yes, we do.
We do. Our limit tool number, I'm like a weatherman now looking over at the board. Limit tool number 5 allows us to take this limit inside and I'll read it off. So I'll have the limit as x approaches c of 2 times f of x minus 3 times g of x, all of that raised to the 1/2. I'm not making a proof, so I don't need to provide justifications, but it is limit tool number 5. Is the limit of a sum the sum of the limits? Is a limit of the sum the sum of the
Yeah.
limits?
Yes.
So
Yeah.
let's use that. Let's distribute my limit across the minus. The same thing works for differences. So this is the same thing of all that stuff raised to the 1/2 of the limit as x approaches c of 2 times f of x minus 3 times, next step, minus the limit as x approaches c of 3 times g of x. And if you look at your limit tools, it's essentially limit tool number 2. It's essentially limit tool number 2. Can I take the 2 and the 3 and bring them in front of the limit? Can you take those 2s and 3s and move them in front of the limits? And the answer is
Yes.
yeah, that's limit tool number 1. That's limit tool number 1. So then I'd have all of this stuff raised to the 1/2, then 2 times the limit as x approaches c of f of x, minus 3 times the limit as x approaches c of g of x. All of that raised to the 1/2, just using limit tool number 1. I'm not making a proof, so I'm not writing it down. I'm not putting my justifications there. Now this is where the genius comes in. We don't know f, we don't know g, and we don't know c. So it seems impossible. But what did they tell me in the very beginning about the limit as x approaches c of f of x? It's the number 7. And this is the number, this limit's the number 4. And so then I've got 2 times 7 minus 3 times 4, all raised to the 1/2. It's at that move you've evaluated the limit. And now it's just arithmetic. 2 times 7 is 14, minus 12 is 2. So it's just 2 to the 1/2 to the square root of 2 by arithmetic. Did you follow that? Did you follow that? Did that make sense? Did that make sense? Okay, now I want you guys to do the similar kind of thing. You're given the same information. The limit as x approaches c of f goes to 7. The limit as x approaches c of g goes to 4. And I want you guys to try to find that limit. Try to find that limit on your own. So you guys have at it. You guys try to find the limit as x approaches c. There's a fraction, and the numerator is 5 times f of x, and the numerator is 5 times f of x, and then the denominator is g of x. Try to find that limit. I'll give you some space to write.
Is that on top? Does that say 5 f of x?
Yep, Miles, that's exactly right. This is where it's so good I can see you guys. So that way I'll give you more time. That way I can give you more time. Okay. Who has a number? Who has a number? Who has a number for me? Does anybody have a number? Does anybody have a number? Zach, what do you got for me, Zach?
Is it 3?
Did anybody else get 3? Did anybody else get 3? Did anybody else get 3? Anybody have another number? Does anybody have, so one answer could be 3. Anybody have another number? What? 3/4? Did anybody else get 3/4? Did anybody else get 3/4?
35 over 4.
35 over 4. Did anybody else get 35 over 4?
What I get?
Okay, 35 over 4. 35 over 4.
I see what I did wrong.
Perfect, Zach. Okay, so let's just go through this. I'm starting here. Is there a limit tool that would allow me to get to there? Let me move on. Is there a limit tool that would allow me to get to here? And you're looking around, and if you look at your limit tools, you're like, hey, Dr. Warren, yeah, limit tool number 4 allows you to do that. What limit tool would allow me to pull that guy out in front? What limit tool would allow me to put that guy out in front?
1.
By limit tool 1. And now you're using the piece of information. They told you this limit went to, in the beginning they told you this went to 7. This went to 4. And there you've got it. So I've got to ask, are these questions really that hard? I mean, once you know it, are they really that hard? Especially if you're not making a proof. They just look really confusing. But they're not really that hard. Okay, stand up again. I can tell you need it. Stand up again. I can tell you need it. Because you're like me. What time does class end? 50. We're at 30. 20 minutes. Oh, just be glad you're young. And your body doesn't feel like concrete like mine.
Dr. Warren, I may be young, but my body is still like 30 years older than I am.
Okay. So everybody bend over and touch your toes without bending your knees. Try to touch your toes without bending your knees. See, some of you guys have no problem. Some of your freaking hands are on the floor. How is that possible? I can barely get below my knees. Below my knees. Oh, okay. Okay, let's suppose we are faced with number 61 in 2.4 on the quest. We were faced with number 61 on the quest. We're looking at the limit as x approaches 1 of a fraction. And that's our heart sinks. Oh no, not a fraction. The numerator is the function x minus 1. The numerator is the function x minus 1. The denominator is x cubed plus x squared minus 2x. And they ask, what does the limit go to in number 61? What's the first thing you should do? Little linebackers? What's your first move, linebackers? Plug in the 1. So go ahead and do that. Plug the 1 into the numerator and the denominator. Linebackers. What do you get in the numerator? That should be easy. What do you get in the numerator? 0. What do you get in the denominator? 0. Can you use the nuclear explosion tool to say the limit doesn't exist? And the answer is no. If this was a plus 1, not a minus 1, then it would go to 2. And then immediately the limit doesn't exist. You're done. You're like, Give me lots of those limits, Dr. Warren, on the test. I like those. Okay? What's your next move, little linebackers? Okay, the guards come at you, you've pushed him away. What's your next move, linebackers? 0 over 0 limits. What's your next move?
Algebra.
Algebra. Try to factor that denominator. Try to factor that denominator. Take out the greatest common factor first and keep trying to factor afterwards. Okay, go to grid view, go to grid view, go to grid view, go to grid view. All right, when you're done factoring, hold it up so that I can see what you got. Hold it up so I can see what you got. I want to see what you guys have. Hold it up and hold it up still so that camera will focus on it. Seeing some good things. Yeah. Some of you guys are getting good at factoring. Excellent. I'm seeing lots of good things, guys. I'm seeing lots of good. Okay, make me number 1. Make me number 1. You guys did great. You guys did great. The first thing you notice is there's a what in every single term we can pull out. There's a what we in every single term.
X.
The x. So we yank that out, and we're left with x squared. That's what's left there. You're pulling an x out. You're left with x squared plus x. That's what's left there. Minus 2. Okay, now here's a little hint. Here's a little hint. The limit's going to 1. The limit's going to 1, and we're getting a 0 over 0. The limit's going to 1, and you're getting a 0 over 0. This is the term this term isn't making it 0. It's this term. A term like that makes it 0. So that term must also be in the denominator. That must be one of the factors in the denominator. So you can kind of cheat by just putting it in there and then asking, well, if one of these terms has to be x minus 1, then what does the other term have to be if it's going to be x squared minus 2? And you're like, well, x minus 2. And you can just check.
Wouldn't it be X plus
2.
Oh, thanks. I'm glad. 1.9 high school grade point average. 1.9 high school grade point average. Okay. Thank you. I need you guys. I need you guys. Okay. What limit tool would you use next? What the hell, Dr. Warren? What limit tool would you use next if it was a proof? What limit tool would you use next? Slasher. Slash, slash. So now we're looking at the limit as x approaches 1 of 1 over x times x plus 2. I'm not making a proof. I'm not making a proof. Okay? At this point in time, when you plug 1 in, do you get division by 0? At this point in time, when you plug 1 in, do you get division by 0? So since we're not making a proof, I will actually let you just plug the 1 in and finish the problem. When you plug a 1 in, well, there's no x, you just get the 1. When you plug a 1 in here, you get a 1. When you plug a 1 in here, you get a 1 plus 2, which is a 3. So I get a 1 times 3, or my answer is 1/3, or my answer is 1/3. Good luck seeing that in the beginning. Good luck seeing that in the beginning, that the answer will go to 1/3. Does this make sense? Does this make sense? Okay. I mean, you can expect problems like that on the quest, where it's a 0/0. And you're like, Dr. Warren, that seems like a pretty odd case, 0/0. And I know some of you are zoning, so let me. Well, Dr. Warren, that seems like a pretty odd case, 0/0. Welcome to Disney, boys and girls. So, let me tell you. So, when you think about calculus, it's about limits, derivatives, and integrals. What's calculus about?
Limits, derivatives,
Limits, derivatives, and integrals. The derivative, which is where we're going to spend most of the class, is defined in terms of a 0/0 limit. What did I just say?
Doctor, we're not gonna be real honest with you. I'm focusing more on your voice than I am what you're doing.
But you're focusing. That's what I knew. If I talked at all, you guys can just go into that marijuana trance. And I look up there at the grid and okay, now I'm going to say it in the quiet voice, the gentle voice. The derivative is defined in terms of a 0/0 limit. What did I just say? What did I just say?
Derivative is defined of a 0/0 limit.
I can't believe I'm filming this crap. I mean, remember, what happens in 205 stays in 205. What happens in 205 stays in 205. It's defined in terms of a 0/0 limit. So even though this seems so obscure, how often is this actually going to occur in reality? That you're going to have a 0/0 function. The derivative is defined as a 0/0 function. So that's why we're just investing so much energy into this. Okay, I have 10 minutes, and we've got to deal with Frankenstein functions. We've got to deal with limits of Frankenstein functions. So you might as well stand up. I can tell you already need it. So stand up, stand up, stand up, stand up. Some of you guys are just thinking what you're going to eat. That's right. That's what's going on. That's the most important thing in your head. I'm going to eat this for lunch. Okay, now since you're at home, what I want you to do is I want you to walk like Frankenstein. Walk. Some of you guys aren't walking like Frankenstein. Okay, if you saw this walking down Main Street, you can sit back down. You would say that's a drunk student. You would say that's a drunk student. Okay, but if it was big and green and had things on his hair and was about 7 feet tall and was coming at you like this, chances are you'd be like, whoa, 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 I don't think I want to deal with this. And Frankenstein functions are just as scary and they're just as difficult to deal with, but they're really easy to spot. They're really easy to spot. They look like this. Let me just make sure I wrote one down. They look like this. F of x equals. You're like, okay, Dr. Warren, that doesn't look any different than anybody else. Then you see one of these. And that's when you're like, what does that say? What does that say?
Oh crap.
Oh crap. It's a Frankenstein function. And you're going to want me to deal with limits of this thing? Okay, so Dr. Frankenstein goes to the graveyard and digs up dead bodies, sews them together to create a single body, a single thing, okay? Shoots it full of electricity, and it becomes an alive function. It meets the definition of a function. What's the definition of a function again? Damn it, Dr. Warren. No, that's not it. A function is a... Good. I've done such a great job.
Relation.
A relation that...
Assign
assigns to each element in one set called the,
Domain.
a unique element in the second set called the range. That unique thing says it can't be more than one, and that's what makes it a problem. We've got two dead bodies in this case. So my top body is going to be the function negative x plus 1, and my bottom body is going to be 2x plus 3. Now it's got to be a function, so it's got to meet the uniqueness requirement. And that's what makes this hard. We can't have this be the function for all real numbers, and this also be the function for all real numbers. You're completely destroying uniqueness. So what we do is we chop up the domain, and in this case, let's just do this. We say we'll use this function whenever the domain is less than or equal to 0. And we'll use this function whenever the domain is greater than 0. We know this is going to be hard, but is it a function? Is that a legitimate function? Would that then be a legitimate function? If you're only going to use this part if x is less than or equal to 0, and this part if x is greater than 0, is it a legitimate function? And the answer is yes.
Yeah.
Now imagine they ask this. What's the limit as x approaches 0 of f of x? And that's where the whole horrorness of Frankenstein comes in. You're like, Dr. Warren, that's impossible. And you might say, oh, Dr. Warren, it's this got the 0. This got the 0. No, doesn't matter. Doesn't matter at all. It's a limit. It's about a limit. This is what I want you to do when you have to attack these kind of problems. They're mean because they're asking for the limit as x goes to 0, and that's exactly where we sewed the body together. So just draw this. Draw a Frankenstein. So draw yourself a Frankenstein. Draw yourself a Frankenstein. This is where we're cutting him in half. This is where we're cutting him in half. This is the 0. This is the 0. When it's less than or equal to 0, the bottom half is using the function negative x plus 1. The top half is from the dead body. The top half is from the dead body 2x plus 3. So this is the way I want you attacking this. Draw a number line. Draw a number line. Draw a number line. Draw a number line. Okay, put the dividing point. In this case, it's 0. Put the dividing point where we change the bodies. Put the dividing point on the number line. Put the dividing point on the number line. This is the way I want you attacking these problems. Now, when it's less than or equal to 0, I'm using the function. When it's less than or equal to 0, don't make me go Mickey.
Negative x plus 1.
You're like, Dr. Warren, damn it, anything, I'll do anything. Negative x plus 1. So put that function on that side, the less than side. When it's greater than 0, I'm using this dead body, 2x plus 3. So put that on this side. The only way you can answer this limit is with one-sided limits. The only way you can answer this question is with one-sided limits. Look at limit tool number 10. Look at limit tool number 10. The limit as x approaches c of f of x equals L if and only if the one-sided limits both equal L. If and only if the one-sided limits both equal L. Why are we doing this with 3 minutes left in class? I know you won't listen at all. Oh, I give you the power to focus. I give you the power to focus. I look at the limit as x approaches 0 from the left of f of x. Write that down. Now go to your number line. Go to your number line. If x is approaching 0 from the left, are you on this side or that side? Answer this or that. Are you on this side or that side?
This side.
This side. So f of x is this function, and we drive that in there. Since we're on this side. Now look at that limit. Is there any division? Do you see any division whatsoever in that limit? Do you see any division? Is there any division? If you see division, then you did drugs before class. Okay. Is there any division?
No.
No. Is there any square roots? Is there any square roots? No, this isn't a proof. There's no problem with this limit. So just take the C and plug it in. Just plug the 0 in. And what will that limit go to? What number will that limit go to when you plug the 0 in? 1. Now let's look at the limit on the other side. Dr. Warren, isn't class supposed to end? Let's look at the limit that goes on the other side. Let's look at the limit from the right. The limit as x approaches 0 from the right of f of x. If you're coming in from the right, are you on this side or that side? Are you on this side or that side?
That side.
That side. So in this case, we're using this function for this Frankenstein creature. So we have the limit as x approaches 0 from the right of 2x plus 3. Again, no problem. No square roots, no division, no possibility of division by 0, no square roots. We can evaluate this limit by just plugging 0 in. And so what does the limit from the right go to? What number does the limit from the right go to? 3. So the limit from the left went to 1. The limit from the right went to 3. What does that tell me about the actual limit as x goes to 0? What does that tell me about the actual limit as x goes to 0?
Does not exist.
Does not exist. This limit does not exist. Both of the one-sided limits exist, but they don't go to the same thing. They don't go to the same thing. Okay, we're going to end class with this question. Could you have made this 3 into a different number so that the limit would exist? Could have you made 3 into a different number so that the limit... What number could you put in there so that the limit would exist and you would end up with the exact same thing?
1.
If you made that a plus 1, don't change it, because we're not changing the problem. If we made it a plus 1, then the limit would exist. Okay. I want you guys working in the homework in section 2.4. Working in the homework in section 2.4. And then reading about continuity. Reading about continuity in section 2.5. Okay? You guys are great. Thanks for coming and playing with me on Friday. Reddish knob, bare fence rock scramble, bare fence rock. Just embrace this weekend. Get outside. Enjoy the sunshine. I want to see tans on Monday. That's part of your homework is to get a tan. Part of your homework is to get a tan. Not too dark. We don't want that cigarette look, okay? Sorry, I mean, you know, the person that looks like they just smoked all their life, they're wrinkled, and then you walk, sorry, okay, I gotta stop. Be free, little lions, be free, run into the wild. Bye, guys.
Thank you, Professor.
Get it
Thank
back.
you. Oh, I gotta stop that camera. Crazy days. Poor kids having to learn like this.